Now, if I can find my chalk. Okay, you gotta take these things one step at a time. Now, there's a point to all that. Okay, I've been sick. I was able to meet my classes. Uh, Sick enough that I don't always connect my steps very well. Okay, when I'm doing math, pretty much okay, but I'm doing other things like avoiding walls and trees when I'm walking around, you know. Okay, well, anyway, the point is, when you're doing this, you gotta do it step by step. That's my whole point. So what do you want to start with? Okay, well, we can start with axis intercepts. Now, what I see everybody doing, and people have often done either the right thing or pretty close to the right thing, okay? But when you're doing these, you need to drill yourself. You need to develop the right habits, and as I've said, that involves writing things out. Okay? Now, if you can do it some other way, okay, but you just dive into some equations and stuff like that, and don't really clearly tell yourself why you're doing this. Here are the axis intercepts. Y-intercept, X-intercept. And immediately when you write down Y-intercept, you write down X equals 0, because that's where the Y-intercept occurs. On the Y-axis, the X coordinate is always 0. On the X-axis, the Y coordinate is always 0. And that's a very simple idea that you can convince yourself of, but if you don't stop and think about that, you're going to be likely to screw it up. Okay? And if you don't write it out like this, then when you have to do it with a polynomial function, or exponential function, or logarithmic function, all which is coming up, you're going to be less likely to do it, and you're going to be stumbling over it when you need to be learning about polynomial functions and exponential functions and logarithmic functions, okay? So X-intercept Y equals 0. So, well, Y equals 2x squared plus 8x plus 4. So 2x squared plus 8x plus 4 equals 0. And it's minus 4. If you use plus 4, that's okay. It's not going to make a whole lot of difference. It's going to be an irrational solution anyway, I think. So here we have it. So what do we have here? Well, now I see people trying to add 4 to both sides of this equation, because of course you have that habit with linear equations. You get all the x's on one side and all the y's on the other. Of course, you've been through an assignment on quadratic formula, and you should be over that. Okay? If you're not, I suspect you didn't write things out as completely as you could have when you did quadratic functions. Fortunately, it's easy to remedy in this case, but I'm just talking about how you approach the course and how you approach learning things, and how important it is that everything you learn is going to be a building block for the next thing you do. Okay? So this is you got to recognize this is a quadratic equation. So X is going to be -8. And I'm not going to write out the details here. I'm just going to screw them up my own. Okay? 8 squared is 64. 2 times 4 is 32, is 8, and 8 times 4 is 32. So it's going to be 109. Oh, darn. Looks like it's going to be 196. All that divided by 4. If I've got this right, and check it. Let me just double check. I've got 64. And I've got, something's wrong there. I've got 196, but I don't believe it anymore. It's not 196, it's 96. Okay. mental lapse there, sorry. Uh, okay, well, that's -8/4, which is -2. Square root of 96 is a square root of 16 times 6. And I'm not going to get into that detail, although it's kind of important. So I'm going to say this is approximately equal to, well, square root of 96 is a little less than square root of 100, which is 10. I'm going to say it's like 9.8. And 9.8 divided by 4 is about 1.65. I think that comes out -3.65 or -0.35. The other thing is this number here gives you your axis of symmetry. Because this number is halfway between these two numbers. I mean, what do you do to this number? You add something to get one number, and then you subtract the same thing to get the other number. So this number is exactly halfway between these two zeros. So when you're using the quadratic formula, you really want to write it out. It's -b/2a, which is -8/2 times 2, which is -2. And that agrees with this number because that's, of course, where this number comes from. You would do well to understand that. Or you can use it as two separate formulas. You don't even have to see this within the quadratic formula. If you want to memorize stuff, you don't really have to memorize. Okay, I think I've got a question coming up here, so let's see what we can do about that. Okay, now we just had a question, somebody who's using a calculator to do this stuff, which can also be a little bit, I don't want to say distracting, but it kind of glosses over some of the arithmetic, okay? And what we were seeing was somebody said, well, I've got a -4ac and my -4ac is 32. So shouldn't I be subtracting 32? Okay. And no. You've already used up the minus when you did -4ac and got 32. Okay. And you want to be really careful. That's why you want to write it out on paper, every step. Okay. Even if you're using a calculator to do the arithmetic. And hopefully, y'all are smart people. You ought to be able to do this arithmetic without a calculator. And when you get down to these square roots and stuff like that, yeah, you're probably going to need a calculator. Okay. And when the numbers get much bigger, at some point, you're going to lose the ability to do the arithmetic. Try the arithmetic first before you punch the calculator. Unless you have ridiculous numbers to start with, you know you're going to need a calculator. But if it seems even remotely possible that you can do this without a calculator, do it, because you get a better feel for the numbers, you get a better feel for the functions, you get a better feel for whatever it is you're trying to analyze, including a business cycle or a financial operation or a decision, a life decision. Okay? You want those big decisions to be informed by as much as possible, including some mathematics. Okay? You don't want to be necessarily controlled by the mathematics because you want to know where the mathematics comes up short. So it's a big deal. You want to develop an intuition for the mathematics and ability to do mathematical analysis. And then to know what your limits are. Okay, anyhow. Okay, the x-intercept occurs when y equals 0. Well, that's easy. That's easy. Yep. Oh, you know what? I did this whole thing by letting y equal 0 because I didn't look at what I'd written. So I've got to change what I did. I think this is just a symptom. Of the moderate cold or whatever it was I had this week, but not necessarily because you see me do this sort of thing all the time. Okay, x-intercept when y equals 0. So we let y equals 0, and here's what we get. Okay, the y-intercept when x equals 0, that's easy. You get y equals 2x squared plus 8x minus 4 equals 2 times 0 squared plus 8 times 0 minus 4 equals -4. That's it. Y-intercept is almost always very easy. Because all you got to do is plug in x equals 0. And if it's a function, there's only one y-intercept. If it's a quadratic function, you can easily have two y-intercepts. Of course, you could easily have no y-intercepts because this number under the square root thing, this number under the radical could be negative and they'd have no solutions. So you have to be careful about all that. So anyhow, there's axis intercepts and the axis of symmetry. So we can now start sketching a graph. The axis of symmetry is where I want to start because everything is symmetric without axis. I'm going to draw this dotted line here. X equals -2. This is the axis of symmetry. And notice that I write this down. Okay, I don't need to write this down. I know what it means. Okay, if I'm working very carefully through a problem and want to trace errors, if I happen to get this wrong, it'd still be to my benefit to label this. In your case, it's to your benefit to label this because you're still learning this and you need to understand that you've identified your axis of symmetry. Don't just slop it down and forget what it means. Write it down and you're going to be four times as far ahead as if you don't. Okay? That's not, that four times ahead thing's not based on valid psychological research, but I'm sure it's right because I think it is. Okay. Seriously, I can say you're way ahead if you write this stuff out, and I urge you to do that. And I do want you to bring the work you do on your homework in a dedicated notebook to class so I can look at it. Not so I can tell you, aha, you didn't do what I said. Okay? So I can identify where it is you're disconnected. If you are disconnecting, and hopefully you're not. Okay. Then I can't do anything if I don't see the work. And I can't believe anything I see in open math because open math gives you way too much help. Okay. Okay. So x equals 2 is your axis of symmetry. Then your zeros are at x equals -3.65. Well, x equals -3.65 is almost x equals 4. A little less than that. I'm going to just say this is x equals -3.65. And then we'll have one over here. For x equals -0.35. And we know that this point is on the graph and this point is on the graph. And we also know that the y-intercept Uh-oh. I've got a big problem here. It must be something wrong with my arithmetic. This y-intercept is at -4. Square root of 96 is almost 10. That's about 2.5. Oh, okay. Now, by labeling all this stuff, and I pretended to make a mistake here, so I could illustrate the advantage of labeling everything. Okay, my problem is I know that when x equals -2, my vertex is going to be at, well, 2 times 2 squared is 32. That's going to be -32 minus 4. Oh, come on, that's it. -2, I'm sorry, -8 minus 16 minus 4 is -12. Okay. So I'm going to find that my vertex is at -12 down about here. And my y-intercept has to be at -4. Now, how can I have a parabola that goes through this point, this point, this point, and this point? It can't be done. Okay, it goes through here, here, and here. And that's got to look like this. It's got to come up and have y-intercept above the x-axis. Well, when I divided something a little less than 10 by 4, I actually messed it up. Should be about 2.65. Now, there's an advantage of using a calculator. You don't screw up things like that. And that's going to change my numbers here. And of course, that's going to change my picture. Got a question? Okay, now, fortunately, it's easy for me to clean off a portion of the board here. And if you're working problems on paper, it's easy to tear out a sheet of paper and throw it in the trash can. Okay, if you had that picture on a sheet of paper, well, maybe you just exit out if you got a bunch of other stuff on that sheet. I try to emulate Einstein as much as possible. Okay, I always consider myself kind of Einstein. I was not quite as bright. And he said the most valuable piece of equipment that a mathematician, physicist, a theoretical physicist has is the waste paper basket. Throw the bad stuff in the trash can and keep the good stuff. So I just threw that in the trash can. And please don't think I'm comparing myself to Einstein. Okay. Here we go. Here's your y-axis. Here's your x-axis. And here is your y-intercept, a little bit to the right of the arc. Your x-intercept. X equals 0.65. And then you have x equals -2. And over here, x equals -4.65. So that we have reasonable x-intercepts. We have our axis of symmetry. And we have y equals -4 here to the y-intercept. Now, with that information, we can think that, okay, it's probably going to be kind of a shallow parabola, probably. Or That messed up. Okay, there it is. Another one for the trash can. But, maybe look something like this. Okay, the one thing we haven't calculated is the vertex. The vertex is on the axis of symmetry. So it's not write out these words. Use abbreviations if you want to. And connect these things logically. We're on the axis of symmetry, so x equals -2. Thus, y equals 2 times the square of -2 plus 8 times -2 minus 4, which I think comes out -12. I didn't write 4 in the. But yeah, that's going to be 4. That's going to be -16. And minus 4, I guess it's going to be, no, it's -2 squared. Okay, it's going to be 8 minus 16 is -8 minus 4, -12. So here's my vertex. Y equals -12. And that makes reasonable sense in terms of the parabola I just messed up here. Okay? Everything is consistent so that my picture is pretty consistent. And now I think maybe I've got the right function. Maybe I've got the right graph. Now, the next question I pose is what transformations are used to graph this function? Well, transformations we start with a basic toolkit function. Okay, what basic toolkit function are we going to start with to construct this graph? That's the one from here to the x squared. Okay, so the function that gives you a parabolic shape, you should know very well is your toolkit squaring function. You should know this has basic toolkit squaring functions, x squared function x squared. That's why we call it the squaring function. Okay. We start with basic toolkit function f of x equals x squared. And vertex is at the red dot. So your red dot's going to end up here. Now, where does your red dot start? For this function, where's the red dot? It's at the origin. You need to know that. It's not always, well, yeah, pretty much always is at the origin. The scheme we're using. Okay. It has to move from the origin to the point -2, -12. So your vertical shift is -12, your horizontal shift is -2. Vertical stretch has to be 2. G of x out of the term 2x squared. If we just do a horizontal and a vertical shift, we always get just plain x squared. To get a 2x squared, we're going to have to multiply by 2. Well, our functions therefore g of x equals a of x minus h plus k. Where this is your vertical stretch. H is your horizontal shift. And k is your vertical shift. So this is a f of x minus h. If f of x is x squared, f of x minus h is x minus h squared. So there it is. A is 2. H is -2. K is -12. So it's 2 times part of the x plus 2 squared minus 12. Okay, well now, g of x is this, g of x is also this. They have to be the same. Well, they are, yeah, and only a better one like that part out. If you don't want to deal with that concept. Yeah. If this comes out to be the same as this, which is entirely possible, then we did it right. Well, we square x plus 2, we get x squared plus 4x plus 4. And we multiply through by 2, we get 2x squared plus 8x plus 8 minus 12. So now 8 minus 12 is minus 4. We get 2x squared plus 8x minus 4 equals 2x squared plus 8x minus 4. Put a check mark there. We checked ourselves. With a note, we finally done good. Okay? Now that's a lot of steps. But if you write out the steps and write out what you're doing and do this a sufficient number of times, you will understand it. I can tell by the work you're doing that that's within your grasp if you have enough hours and choose to spend them. Okay? So that now we can take our picture. I'm just going to make a small picture. Here's our toolkit scoring function on a 4x4 rectangle with the red dot. Out here. And what we do is we vertically stretch it. And we did this last time, because it's detail. We vertically stretch it, this rectangle becomes 8 by 4. And then take our vertically stretch route. In an 8x4 rectangle. And we just move that rectangle over a couple of units and down 12 units. So the line x equals -2, which is our axis of symmetry. Let's just look back at how we got all this, okay? Our axis of symmetry is that x equals -2. And our vertex is at y equals -12. So let's see, if this is 8, well, -8 would be here, -12 would be about here. Here's y equals -8, and here's our vertex. Here's our 8x4 rectangle. And it actually comes over to the y-axis because it's over 2 units here. And now here's our graph. And I extend it a little beyond our rectangle. And I get a graph that's a good representative of this graph. Well, that's the process that I'm going to be telling you. And it's probably the primary process that I'm going to be testing. Now, if you can do parts of it, you can get partial credit, but the more of it you put together, the closer you get to a really good grade. And also, I mean, another payoff of this is that when you finally get this to work out and see all this consistency, it really feels pretty good, pretty neat. Okay, it's like you got this puzzle and all of a sudden you put it together. Now, some people are bigger on getting their puzzles put together than others. But a lot of people get a lot of satisfaction about putting a puzzle together, okay? And there's a lot of that in mathematics. Got a 10-year-old grandson who's pretty good at putting puzzles together and Lego models and stuff, okay? And he does fairly well with his mathematics. Maybe pretty well. It's a little early to tell. So we're hoping that we can leverage some of those, or we can help him leverage some of those concepts. Okay. This is something that's really easy, but people always ignore it. And then it comes up on the next test, and people don't know how to do it. And people go through life not knowing it. And that's something you really need to know. First of all, y is directly proportional to x if not is y equals kx for some constant k. All right. So what would I mean? What would I write here? Okay. What would I put here? This is what it means to be directly proportional to x. What does it mean to be directly proportional to x cubed? You don't want to think too much. You do the obvious thing. Okay, so hopefully having studied construction notation and stuff, you would know that this says exactly the same as this, except instead of x, I've got x cubed. So instead of x, I'm going to write x cubed. It's kind of like function notation, but not the same thing. Okay. Okay. So we need to get that straight. Normally I start doing examples with this and then people never make the transition to other types of proportionality or what open math correctly calls variation. I don't want to use two different words for the same central thing.
Can I?
But here's what it means to be inversely proportional. Instead of y equals k times x, it's y equals k divided by x. And then y is inversely proportional to x squared if y equals what? Go ahead and write it down. Okay, so what you got is y equals k over x squared, okay? See the pattern here? Now, if y equals kx, then if x gets bigger, does y get bigger or smaller? Bigger, because if you multiply a bigger number by the same number, you get a bigger number. Over here, if x gets bigger, does y get bigger or smaller? Small. Because if you divide by a bigger number, you get a smaller number. Okay? So we have to have that intuition. And of course, if x is cubed, then y gets bigger. Okay, if you cube x, it gets bigger and bigger. Okay? So, and if you square x, it gets smaller. Okay. Now, y equals kx, y equals 8, when x equals 2. What's the value of the constant k? So you got it, just show me with your fingers. Put in 2 for x and 8 for y. And you can solve that equation for k. So what we do is we find k. And then we write our equation, write the equation with our value of k. I'll say y equals kx becomes y equals 4x. Okay? Any difficulty there? Pretty straightforward. It is. In every case, it's very straightforward if you follow the steps. So again, I urge you to write out the words so that you understand the steps. Or if you just want to do the steps a couple of times and then start writing out the words to put it together, that's okay too. But eventually you need to be able to solve this problem with all the words I'm using here, or you're improving on my word, okay? Or your version of the wording, but it needs to be logically and mathematically correct. Not just one way to write it out. Okay, so now if x equals 12, what is y? Oh, there is two. Got time for one more at least. Y is inversely proportional to the square root of y, and y equals 8 when x equals 4. What is y when x equals 36? Okay, so say if y is inversely proportional to the square root of y, x of x, and y equals 8 when x equals 4. What is y when x equals 36? We always start out by writing out the proportionality. Right here are examples of how we would write out a proportionality. So what are you going to do? What's your proportionality going to be? And I'm not surprisingly, did this stuff for the first time, but we have our pattern here. Okay. What have we always done? It's always been inversely proportional with some power of x, right? And in an inverse proportion, the x goes to the denominator. So if it's inversely proportional to x squared, that would be y equals k over x squared. Well, first write the proportionality. So that is, we just follow the pattern that we see here. Don't think about anything else. Don't think of what you're going to do next, because it's always very straightforward. Okay? One step at a time, y equals k over the square root of x. Then use our x and y values to find k. Now I'm going to complete this. I want you to understand how straightforward this is. Okay? Y equals 8 and x equals 4. So that 8 equals k over 2. So 4 being 2. And then k is 16. this is always an easy step. You just have to know how to break it down in easy steps. Okay, so the next easy step is I'll say write the specific proportionality. And maybe here I should say write the general proportionality. General proportionality doesn't have specific values of X and Y. Once you use specific values of X and Y, then you get a specific value for K, and you can replace K with that value. Y equals 16 over the small root of X. Now we find Y for the given X. Y equals 16 for the we'll call it the given X, I'll call it desired X. The X you want to find it for. That's your 36. How many ways to write that out, but 2 2/3 is one of the ways. You understand that every step is really simple. Okay? There's nothing to it. You just have to break it down and follow the steps. And people have a tendency not to do this. Okay? Don't be those people. Okay? Have a good weekend.